Ladies and gentlemen, here we go. Section 5, Chapter 9. Question is, how do you find the distance between any 2 points, no matter where they are, on the coordinate plane? Now, I'm going to tell you how this comes about. The distance formula is really derived from the Pythagorean Theorem. Hence is why it's after the Pythagorean Theorem we just talked about. So let me show you how this works. Let's say you were proposed a question like this. You had the coordinate plane over here, y-axis, x-axis. And it said plot these 2 points 3, 6 and 11, 10, but the question said find the distance between them. Well, I'm going to tell you, I'm going to show you how to use the Pythagorean Theorem. So this example should go in your notes, and let's start plotting this bad boy. So here we go. So let's say that this is 3, 6. Here's 1, 2, 3, 1, 2, 3, 4, 5, 6. So right here is going to be point 3, comma 6. Okay, that's pretty simple. This point here, 11, 10, let's go over here. So there's 3, there's 4, 5, 6, 7, 8, 9, 10. We already know that this, wait, I need 11. 11. This up here is already 6, so 6, 7, 8, 9, 10 is right there. So there is point 11, comma 10. Lovely. Now, the question says again, what's the distance between those 2 points? So the question is, what is the distance between there? Well, now here we go. What I'm going to do is again show you how to use the Pythagorean Theorem to make this come about. And here's what's going to happen. I'm going to draw from this point here, 3, 6, I'm going to draw a line, extend it over here if you will, parallel to the x-axis, parallel to this x-axis right here. And I'm going to stop it right there. So I've just kind of extended that. And now I'm going to draw a line likewise from point 11, 10, and I'm going to draw it straight down here parallel to the y-axis, stopping it right there at that point, creating another point right there. And yes, you looked at it and you guessed it, there's a triangle. Is it a right triangle? We don't know that yet. Oh yes, we do, because if this is the y-axis and this is the x-axis, we know they're perpendicular. And I just told you I drew a line parallel to the y-axis and parallel to the x-axis. So that means, ladies and gentlemen, we got ourselves a right angle. And oh yes, that means we have ourselves a right triangle. So bada bing, bada boom, we can use the Pythagorean Theorem. And notice what we're actually trying to find. The distance between these 2 points is nothing more than our friendly little hypotenuse. So that is what we are trying to find right there. Smiley face to you. So let's say that this hypotenuse is C. Whatever, we're going to call it that. It can be any letter as we talked about before. So here we go. How would I do it? Well, I need to find this leg length right there. How do I do that? Well, here's what I know. I know this point over here on the y-axis happens to be going through that y-coordinate. So there's 10. I also know this point down here is going through the y-axis, or the y, I don't know, whatever I'm going to say. It's at a y distance coordinate of whatever this one is. So 6. So what's the distance between these 2 points on a vertical line? It's simple to do, because down 10 to 6 gives you this. Nothing more than just taking 10 and subtracting away 6. Now remember this, because I'm setting the stage for what we're going to do here in a little bit. So I'm taking 10 and subtracting 6. That would give me 4. So that's one of the leg lengths. So you know what? Since I know my Pythagorean Theorem is a squared plus b squared equals c squared, and I'm trying to find c squared, let's take this 4 and plug it in right here. So I know I am that far in the game. Well, what's the distance here? I need to find this leg length. Well, here we go. Same argument and concept applies. This x-coordinate right here happens to be right there on 3 on the x-axis. This y-coordinate happens to be the same y-coordinate as that, so that's 11 down there. So I just take, here we go, 11, subtract away 3. The distance between those 2 points is just taking the bigger one, subtracting the smaller one. Same thing here, bigger y-coordinate, subtract the smaller y-coordinate to give us that. Because we're talking distance, we're talking all positive. And this happens to be 8. So there's my other, folks, leg length. Let's put it in over here. So there we go. So when I solve this bad boy out, you can do it right now. I'm going to pause the video, and I'm going to get through some of this and write it up, and then we're going to start it again. Okay, so here you go. So I've written this out. You probably already did it too, but here you go. 4 squared is just 16. 8 squared is just 64. Add them together, that gives me 80. I take the square root of both sides, and yes, it's plus or minus, but disregard the negative. because we're talking side length now of a triangle, and you get the square root of 80. But be careful. That, remember, is not your answer. You have to keep going. You have to break up the square root of 80. I'm going to come up here because I'm out of room. So the square root of 80 breaks up into biggest perfect square would be 16 and 5. So it looks just like that. So that means when I take the square root of 16, that means it goes to a 4. It's out of jail. Square root of 5 stays square root of 5. And ladies and gentlemen, there is the distance between those 2 points. It's the hypotenuse length. It's just 4 root 5. So from here up to here is 4 root 5. Phenomenal. Now, let's do this as a vague general example. Let's label this as y-axis. Write this on your notes. Label this as the x-axis. And here's a random point I just put on there anywhere, being very vague. So let's call this point A, and I'm going to label it as x1, y1. You should as well. This point up here, I'm going to call point B, very vague as well. I don't know what the coordinates are. I'll just make them x2, y2. And what I'm going to do is, again, the same thing. Find the distance between these 2 points. So I'm going to do this very vague, very, very vague, so you see how this comes about. The Pythagorean Theorem derives us the actual distance formula. Couldn't think of the word. So here's how we're going to do it. Same thing. Let's draw a line parallel to the y-axis that comes down here. We'll stop it right there. And I'm going to draw another line parallel to the x-axis and make ourselves a right triangle, just like we did in the last example. Now this point right here, where they're intersecting, we're actually going to label that one. We need to label that one so this works. We're going to call that point C. Now, I don't have the coordinates in here because I want to make sure you're clear on this. What would the coordinates of this thing be right here? Well, it's the x-coordinate, and it's the same x-coordinate if I keep going up is what B is, because that x-coordinate right there, if I keep going down, is the same thing as x2. So that means this x-coordinate for C would be x2. Likewise, over here, what's my y-coordinate? Well, that's my vertical distance, my vertical change, my vertical whatever. So that means it's right through here at that point, and that happens to be the same y-coordinate as A, so that's y1. So this happens to be y1. Now, we know we're trying to find the length of the hypotenuse. I have to label that as a different letter because it's C. I don't know, let's label it as H. Why not? Hypotenuse. There we go. So, I'm looking for the hypotenuse squared, and I know that's going to equal the one leg length. We'll call it A squared. And we'll call it the other leg length B squared. That's just straight up Pythagorean Theorem. Well, let's dive into this a little more. What is the distance, aka what's the length, whatever, from B to C? Well, if you go back to the other example that we just did, we went 10 minus 6. So the biggest x-coordinate here, or y-coordinate, sorry, minus the smaller y-coordinate there. We do the same thing in this example. So I take y2 and I subtract away y1. That's this, subtract away this. That's the same thing as what we did in the other example of 10 minus 6. That's a representation of what this distance would be. Okay? Likewise, right here, if I wanted to find the distance between those two things, aka the length of that leg, aka the length of AC, I would have to do the same argument. Back here, I'm taking 11 subtracting 3. The bigger x-coordinate, subtract away the smaller x-coordinate, that happens to be this. The bigger x-coordinate, which is x2, I'm going to subtract away the smaller x-coordinate, or the other x-coordinate, whatever, which is x1. And I will put parentheses around that because that's the representation of that leg right there. Now, let's put it into the Pythagorean Theorem. You're going to see how this works. Remember, I'm looking for h squared. So one leg happens to be this. Representation is x squared minus, not x squared, sorry, x2 minus x1. All of that squared, because A, the leg length, is this whole thing right there. And I'll go plus leg length number 2, which happens to be this representation. Oh, this is looking pretty good. y2 minus y1 squared. So there, ladies and gentlemen, is my equation. But it is not solved for h yet. We have to do what? That's right. Take the square root. We have to take the square root of this to clear the square, to undo the square. And I have to take the square root of that whole thing. So what does that give us? Well, first of all, these cancel out. And what you're left with is h, and then underneath the big old square root sign, oh, that looks familiar, it better, x2 minus x1 squared plus y2 minus y1 squared. I love it. What is that? Nothing more, ladies and gentlemen, than your friendly old distance formula. So we just derived the distance formula by using the Pythagorean theorem. So what should officially go into your notes for the theorem? It's right here. It's Theorem 71, denoted in your book. Wonderful. If we have any 2 points, don't care where they are, don't care what they are. They can be positive, negative, doesn't matter. We'll practice a bunch in class. And another point, x2, y2. The distance between them can simply be found by doing this. Take the difference of the x coordinates. It's basically just doing this. What's the change in x? And you're squaring that, and you're adding that to basically just the change in y. And square that. And then you square root it all, and ba bing, you have the distance formula. Congratulations. There you go. Looking forward to practicing this in class.